Ricardo Valerdi here from the University of Arizona Department of Systems and Industrial Engineering, and I'm joined by Professor Barry Boehm from the University of Southern California Center for Systems and Software Engineering. Thanks for joining us, Barry.
You're welcome.
So let's talk a little bit about software cost estimation, which is your contribution to the profession. And in particular, I'm wondering if you could say a few words about how you got started in this area.
Okay. There was sort of an early start when I was working at the RAND Corporation and ran a study for the Air Force on what were the technologies they were going to need in the 1980s, and this was 1971, and particularly the information processing technologies. And they had expected it to be big computers and big displays, but what we found when we went around to the Air Force bases and the like was that the big problem that they had was with software. And so we did a projection that said right now software is about 30% of the budget and hardware is about 70, and it's going to be 70-30 by the time you get to the 1980s. And so I got interested in trying to get data on software costs, but working for the RAND Corporation, the biggest project it had in programming was about 4 people, and so I decided to try to work for a company that was doing a lot of software and went to TRW. And so my job there was called Director of Software Research and Technology. And whatever kind of technology the company needed, I was supposed to figure out a way to get it improved and pick some people to push it along and that sort of thing. So one day in 1976, the division general manager called me into his office and said, over the past 3 weeks, I've had to sign 3 proposals, and each of them had a budget of about $50 million for software. And I asked the proposers, how do you know it isn't 25 million or 75 million? And they didn't have very good answers. And so we need to do better than that. And so I'd like your top priority over the next few months is to try to figure out a better way for us to estimate the cost of the software so I can feel more comfortable when I sign these proposals. So fortunately, if you have the division general manager backing you up, you can get people to give you data, you can get experts to work with you on developing a model. And so we got data on about 20 projects and developed a model that had a size as one cost driver, and then a bunch of things that were people-oriented and project-oriented and product-oriented that were also cost drivers. And so there were a bunch of functional forms around, and one of them was something called the Doty model, which it basically said you want to have a size to some exponent modified by some other kind of factors, and this looked like a good thing to do. And the way they had done it was not really doing that well for our projects, and so we calibrated something for our projects, and it became known as SCEP, which meant Software Cost Estimation Program. And so basically, it did very well for us. Of the 20 projects, only one was hard to estimate using the model, and this was a project that was being done at an off-site in Dayton, Ohio. And we tried to figure out what the root cause was, and the best thing we could come up with is, if you're a bunch of guys in Dayton, Ohio, what do you do on the weekend? You keep programming. So actually it was a bunch of Purdue grads that knew each other, and they would have barbecues on the weekend and talk shop, and they were incredibly productive anyway. So basically that worked very well for our proposals, and but the government would say, yeah, that's nice that your model says that, but how can we use your model to apply it to our competitors? And at the time, the company wanted to keep it proprietary. But eventually they said, yeah, we might as well open it up. And so fundamentally at that time I was also teaching at UCLA and giving the students assignments that said, yeah, take some of your projects that you're doing at work and see if they fit this model. And for the most part it did, but there were some more tweaks that needed to be done. But fundamentally what we ended up with was something that was good for at least the aerospace type projects. So we had a few business projects and the like. So after that, I was also at one point going to write a textbook on software engineering. This was 1978, and there weren't any at the time. And I worked out a sabbatical where I went to USC for a semester. And so when I got there, fundamentally, I was extremely productive because it took them 6 months to put a phone in my office. And so basically, I was able to churn out about 400 pages, but I'd only covered about 10% of the subject matter, but 200 pages was cost estimation. And so I said, well, maybe I'll just write a book on cost estimation. And that's how software engineering economics got going, and that's what made COCOMO available to the world at large.
So how did you come up with the name COCOMO?
It was, the constructive was basically saying, one of the things we found was that when people were required to come up with the values for the cost drivers and the size parameters for the various things, it helped them understand the job that they were doing. And so constructive was basically saying that, yeah, you're doing more than just getting a cost estimate, you're getting a better understanding of what your project's going to be like. And so constructive cost model, it wasn't the Beach Boys, but it was COCOMO seemed like it was a reasonably easy acronym to remember.
Right. So the focus on understanding software costs probably eventually led to the spiral model as well. So can you talk about the connection between COCOMO and the spiral model?
Sure, yeah. Well, at the time in the 70s, Winston Royce had published this famous paper that described the waterfall model, and he was trying to show that you don't just go one step at a time and don't have any feedback loops or anything like that. He had something that said, yeah, what you really ought to do is do a prototype first and go through the front steps and a little bit of code, and by that time you have a better understanding, and then you can go back and get a better architecture for your real system. Nobody ever looked at that part of the paper. They all thought that the waterfall was sort of the secret sauce. And so TRW actually made that a marketing thrust, and we actually had set of software development policies and standards. And so as the Director of Research and Technology, I was supposed to organize something that would create the policies and standards, and they were really organized on getting people to learn the waterfall model. And what we found was that, yeah, we went out with all this public relations. Some of the projects that we worked on, the customer said, "You didn't build that software that way for us." And so the corporate standards and policies were supposed to be our commitment that everybody gets the waterfall. And we actually came up with an analog of the California driver's test, which had 40 questions, and if you didn't pass more than 35 of them, you couldn't drive a TRW software project. And so we brainwashed everybody in doing the waterfall, but both Win Royce and I were saying it's not just progressive steps like that. There's got to be some feedback cycles and places where you prototype something and then you build on what you learned on that, and maybe you need to do another round of prototyping, and so we actually came up with things. At that time, he left to join Lockheed for a while, and I tried to turn the company around, and after we'd brainwashed everybody to do the waterfall, it was a real challenge to get people to try to do it any other way. So if you said, well, we're going to do a prototype, people said, well, the corporate standard says you can't start programming until you finish the critical design review. And we'd have big arguments where people would pound on the table and you say, prototyping is illegal and immoral. So basically, the spiral was a way to show people that you could do things iteratively, and what we, when Royce and I were talking about things, we'd look at things like statistical decision theory that basically says, what is the risk of going forward, and then how does that help you make a decision? And that's really what came up with the risk-based decisions in the spiral model. And so from there, basically, this got published in the literature, and it just happened to be at the time when this was really needed, because for not just TRW but the world at large, programming it initially was, you build this thing so that you can grind out answers, but in the late 70s and early 80s, people were doing user interactive systems by that time, and you couldn't really write the requirements. You really needed to get the prototype going and get the users to say, no, I don't like it that way, I need something. And if you're going to do that, gee, give me some exception reports and trend analyses, and so you learned a lot about what they really wanted by doing the prototypes. So basically, the spiral model just sort of took off, and unfortunately, the diagram that showed the spiral model was easy to misinterpret, and so if you Google on spiral model images, you'll find a really glorious bunch of misinterpretations of what it was really trying to do. And so as time went on, we tried getting the model-based spiral or the incremental commitment model, and then we decided, well, we better put spiral in there, and just to keep the brand alive and that sort of thing. So that's sort of how it got there and how it evolved.
Great. So one final question about where the field is going, because you talked about COCOMO, which was published in your software engineering economics book, and then 20 years later COCOMO II was published around the year 2000, and so now we're almost 20 years after that. So what's COCOMO III have in store?
That's exactly what we found. What we found was that the old COCOMO was really sort of waterfall oriented, and actually by 1995, when it was 14 years old, we found that it wasn't a good model for estimating things that were going to be done iteratively, and a lot of the technology had gone forward. So something that was very high tool support in 1981 was more like nominal in 1995, and so I was at USC at the time, and you know, fortunately there were a bunch of other people around, like Ray Madicky and Rick Selby and Ellis Horowitz and the like, and so we started COCOMO II in 1995. And it took really 5 years to get it defined and published in 2000. So 14 years later, in 2014, we found that a lot of the assumptions that COCOMO II made didn't account for a lot of mobile software and a lot of systems effects and the like, and that it was time to do COCOMO III. Originally, what we had thought we were doing with COCOMO II was we were building the single cost model that was needed for the 21st century. But what we found in 2014 was that there were all of these different kind of things, and we were mentioning on the drive over here that things like Salesforce.com and the enterprise resource planning packages give you a huge amount of functionality for relatively little effort, so you need some way to account for those, and that a lot of companies were inventing things like rice objects that were saying how many reports and interfaces and the like are we doing, and getting a fair amount of success for them. And so what we've finally concluded with COCOMO III is that it's not a good idea to try to do a single model that covers everything that everybody is doing. So right now we have an activity going on where we're saying what are the main modes of development. So some of them are really agile and lean and DevOps and Kanban and all these other kind of things, and how do we fit all those in? Some of the things involved with systems of systems operate differently and the like. So we're converging on a family of models and trying to come up with a set of criteria that say there is a successor that looks a lot like COCOMO II, and it works for big command and control systems or aircraft systems or things like that, but it doesn't work very well for pure agile systems and the like. And so we're expecting by 2020 to gather enough data and calibrate the model solidly enough so that by 2034, hopefully somebody will be around to figure out, where do we go from here?
That's right. Great. Well, thank you for sharing your thoughts, and thank you for your all the textbooks you've written and the papers you've shared and your contributions to the field. Thank you.
Okay. You're welcome. Right.